All right, welcome back to geometry. This is a Friday. We're going to score lesson 71 and 72. Hopefully we got all the questions answered, or at least most of them answered yesterday. And if you have more questions, then look at this and hopefully this will make sense. If you still have questions afterwards, then ask a fellow student or get in contact with your teacher and see what they have to say. All right, lesson 71. We're scoring lesson 71, lesson 72 today. Lesson 71, number 2. Lesson 71, number 2. A pyramid has a base area of 15 square centimeters, a height of 10. What is the volume of the pyramid? The volume of the pyramid is 50 cubic centimeters. You should have a little 3 after your centimeter designation. Volume is always cubic. 50 cubic centimeters. Number 3, determine whether the measurements 1.6, 1.8, and 3.4 can be the side lengths of a triangle. If it is a triangle, determine whether it is acute, obtuse, or right. 1.6 and 1.8 and 3.4. If I have a 3.4 down here, that is 3.4, and a 1.6 and a 1.8, what will happen? Well, 1.6 plus 1.8 equal 3.4, so they will lay down here flat against, and it will not be a triangle. Number 6, the image of 5 and something after the transformation of something and 11 is 1 and negative 6. We talked about this yesterday. You need to just add them together. For instance, for the x point, the original x point was 5, and something happened to it, and then it became 1. What happened to get from 5 to 1? Negative 4. So the x value is negative 4. And then for the y, it started at some place and it got moved 11 positive, so 11 up, and it ended up at negative 6. So what happened? Where did it start? You have to subtract 11 off of 6, so it started at negative 17 and got 11 added to it, and then it was still at negative 6. So x equals negative 4, y equals negative 17. Number 7, the points as given are translated 4 units up and 3 units to the left. What are the coordinates of the images of the points? So first of all, that they try to confuse you there. You moved 4 units up and 3 units to the left. Well, x is always first, so go with the 3, the left and right. And since it moved to the left, that means it is a negative x movement, negative 3 movement, and then a positive y of 4, positive 4 for y. So if you take 3 off of 5 for the first point, you'll get a 2. So the point P, the answer is 2 and 9, since you're taking 3 off of the x and adding 4 to the y. Take 3 off of Q, Q's x, which is negative 5. Take 3 off of that and add 4 to the y. You'll get for Q, it's actually Q prime, will be negative 8 and negative 1. Again, the points for P prime are 2, the coordinates for the point P prime is 2 and 9, and the coordinates for the point Q prime are negative 8 and negative 1. Number 9, trapezoid has vertices as given. Use the distance formula to find the length of the midsegment of the trapezoid, which we talked about this before. If you do it, you get 2 to the square root of 5, or 4.47 to some number, 4.47 roughly, for the length of the midsegment. And that is using the, you draw it out however it's oriented, and use the distance formula to find this distance, and then find half of that. Since halfway in between, midsegment, halfway in between means it's the average of these two. Add these two together, the distance of these two, and divide it in half, and that'll get you the length of that. 2 to the square root of 5, or 4.47, roughly. All right, number 10. What is the surface area of a regular pyramid with a lateral area of 10 and a base area of 5? Well, they pretty much did the whole work for you. Lateral area is 10, base area is 5. What's the total area? 10 plus 5 equals 15. Good job. 15 square feet for number 10. Number 15. In Paris, there's a glass square-shaped pyramid. The pyramid is about 70 feet tall. The side lengths are about 115. What is approximate volume? What's the formula for volume? 1/3 of base times height. That is the area of the base. What's the area of the base? If it's square and has 115-foot sides, 115 times 115, that's the area of the base. Take that answer times 70, and then divide it by 3, or take it times 1/3, which is what you're doing. The answer, nearest cubic foot, is 308,583. That should be exactly what it is. There's no There's no pi to get involved, so you should only have an answer of 308,583. If someone wants to argue with that, then argue on. But that's the correct answer for 15. Number 16, DEF, triangle DEF is translated so the coordinates of E prime are 0 and 3. What are the coordinates of F after the same translation? And the coordinates of F after that same translation are letter C, which is -2 and -2. So the answer for number 16 is letter C. Number 17, draw a 30, 60, 90 triangle with a longer leg measuring 1. Include all angle measures and side lengths. We will do that here. 30, 60, 90. I always draw them this way, I don't know why. With a longer leg of 1. Is that what it said? Yes. And include all angle measures and side lengths. So the angle measures, this is 90, this is 60, this is 30, and length. So this is 1. Now, typically when we look at a 30, 60, 90, our ratio, we start with a 1 here and a 2 here, and then we go square root of 3. Again, this is just proportion. This is only the proportions. So you can have a leg length of 1 over here, it's just that the proportions are going to be this. So how do we do that? Well, if you're on the short leg and you go this way, you take the short leg times the square root of 3 to get the longer leg. So to go from the longer leg to the shorter leg, you have to divide it by the square root of 3. So it is 1, to go from here to here, it is 1 divided by the square root of 3. That is this. And we're not quite finished. If we take this whole thing and go square root of 3 over 3, and again, that's simply just to get rid of the square root of 3 in the denominator, then you have the square root of 3 over 3. That is the answer for the short leg. Square root of 3 over 3. Now you can just double that to get up to here. 1, 2, since this is always half the size of this. Take this times 2. So your answer up here is 2 times square root of 3 over 3. And you can simplify that further and just say 2 square root of 3 divided by 3. Makes it look neater. It's the same thing. So this is the answer for the hypotenuse of this leg. And you should have all that in your drawing. You don't have to have all this, but that is how we get there. You should at least have this. This is this length, this is this length, and have your measurements as well, angle measures. All right, number 19. Determine the missing side lengths in triangle STU. Give exact answers. Again, it's the same idea. Now we're just going to a 45, 45, 90 triangle. And UST, this is 3.5, is that right? Yes. And 45 degrees here. So again, a 45, 45, 90 triangle is 1, 1, and square root of 2. That's the proportions. So these side lengths will be in this proportion. So to go from here to here, you take this answer times the square root of 2 to go up, and that means to go backwards, you're dividing it. So 3.5 divided by the square root of 2, do the same thing we did over here. Now you're multiplying by the square root of 2 over square root of 2. So you get 3.5 square root of 2 over 2. And you could simplify that further. It says give exact answers, and we could take that a step further. Let's just go ahead and put this in half, which is half of 3.5. If you use your calculator, is 1.75, I think. 1.75 square root of 2. Now we said we don't like that kind of answer because it's decimal mixed with that, but that is the exact answer. That's as good as we can do it. And then it says, so it says give exact answers. That means you should have that. This is the same, by the way, up here as well. Because SU equals ST, and it's 1 to 1. So we're just finding this one. We understand it's this one as well. So this is the exact answer, and then use your calculator and approximate, which is approximately 2.47. So that should be included in your answer as well. You should have both of these for your answer for number 19. All right, number 26. 26 and 71 is again about the same as what we've been doing. This is 71, 26. In triangle DEF, F is a right angle, D is 45, and DE equals 3. Draw a diagram and determine exact and approximate value. So it's exactly what we just did with new numbers. Could have left that one here. Like you're supposed to draw a diagram and Your diagram would be, just copying from here, I'm turning it this way, the book is the other way, but that's okay. E, D is the right angle, F is out here, and no, F is the right angle. F is the right angle, and D is out here, D is 45, and the side length is 3. And it's asking, did I do that right? D is 45, F is the F is the right angle. Yes. All right, DE is 3. Find all the side lengths. Again, it's going to be 1 square root of 2, so 3 divided by square root of 2, so it's 3 square root of 2 over 2. 3 square root of 2 over 2. Your diagram would look like this without this, and now it's asking for exact values. Again, this and these are equal because it's 45, 45, 90. And then approximate value, give exact and approximate values. Approximate value of that is 2.12 approximately. So those are your answers. That's part B of 26. And finally 27. Why did I pick this one? 27. Comes from lesson 57. Pond is overlaid with a coordinate grid with each square representing 5 square meters. Estimate the area of the pond. Take all your estimated blocks times 5 so that you get it. And the book says approximately 120 square meters. If you have anything close to that, that's good enough. All right, lesson 72. And keep moving. If you need to stop at any time, just push pause. One advantage of doing it this way is you can just pause me if you don't want to listen to me anymore, or if I talk too fast. So, lesson 72, number 2. Lesson 72, not number 2. Lesson 72, number 5. Assume the segments that appear to be tangent are tangent, and find the length of BE, the length of CE, and the length of DE. BE equals 17, CE and DE both equal 15. So remember, when you have a point outside of a circle and you have tangent lines drawn to the circle, those lines are congruent. That's your setup. BE is 17 and CE and DE are both 15. All right, number 6. Draw a diagram of 30, 60, 90 triangles with a hypotenuse that is 6 inches long. Label the exact lengths. We've been doing this fairly frequently here recently. That's okay. Practice makes perfect. So the hypotenuse is 6. Keep dropping stuff. And 30, 60, 90. Hypotenuse is 6. And does it say, where are we at? Label the exact lengths. If this is 6, this is 3, and this is 3 square root of 3. Pretty simple. And of course your sides, or your angle measures are 30 up there and 60 down here. 3, 6, 3 is square root of 3. 1, 2 square root of 3. That's the proportion. 1, 2 square root of 3. All right, number 7, the translation of points x and y is x minus 2 and y minus 1. That's applied to a circle with a center at 5 and 4. What happens to the circle, the image, so that's again after the transformation, what happened, or the translation, what happened to the center of the circle. If you take 2 off of 5, you get 3. If you take 1 off of 4, you get 3. So the new circle is 3 and 3. Pretty straightforward, I think. 11. Determine the point of tangency in the equation of the line that is tangent to both circles. Now, this one I think some people had a question on, and it's just basically reading the graph, looking at the graph, find the radius of each circle. First thing is determine the point of tangency. Well, the point of tangency is x is 0 and y is negative 1. So 0 and negative 1 is the point of tangency. The tangent line is, and there's a couple. Remember we said we could do, like for this setup, we could do one through here, we could do these this way, but for this lesson, they're talking about this line right here. The point of tangency is this, and so the tangent line that's connecting both of them at the same spot is this one, and it is at, I don't have a graph, but right here is my origin, that's 0 and 0. So describe this line. Remember, y equals mx plus b. This is slope and this is y-intercept. Well, the line is simply y equals -1. For any imaginable x value, even if x is 359,765,251, y will still be -1. So y equals -1. I don't know if you can read that. Yeah. Y equals -1. That is the line. That is this tangent line right there. And then determine the radius of each circle. The radius, just count them. And it appears like the radius of B is 1. Where are we at? Yeah, the radius of B is 1, and the radius of A is 2 units. All right, number 14. Point K, which is located at 4 and 11, is translated 5 units to the left. What are the coordinates of the image? So K prime, you should have K prime. K prime equals -1, because it started at +4. If this is our 0 and 0, it started over here, +4, and we subtracted 5 off of it. That got us 1 past center, so it's -1 and 11, because 11 never moved. It didn't say anything about up and down. Number 16 is the same as 11, basically. Determine the point of tangency in the equation of the tangent line. This time they're outside. So the point of tangency, it appears like it is at x equals 4, 1, 2, 3, 4, and y is -1. So the point of tangency is 4, -1. The tangent line this time is a vertical line, and here's 0. This is getting complicated. I should start over. Here is 0, and the circles are over here somewhere, and it's down here a little bit, but it's the, what are we doing? Oh, the tangent line. So it's right here is the tangent line. And again, for any possible imaginable value of y, x is always 1, 2, 3, 4. So the line is x equals 4. That's the tangent line right there. 16. All right, 16 and 17. What translation in mapping notation would move the point H to H prime? And it moves from 3 and -5 to 0 and -2. Well, just simply look at what the change. What is the change in the x? The change in the x, it went from 3 to 0. That appears to me like you would take a -3 movement for the x. And y is at -5 and ends up at -2. That's a +3. So in translation mapping, the translation of points x and y becomes x minus 3, is that what I said? And y plus 3. You're subtracting 3 off of x and you're adding 3 to y. Again, like I said, this is really the only pertinent information. What happened to the x? It was a -3. What happened to y? +3. This is the whole formula there is, or that whole framework is the mapping notation it's called. Number 19. What is the relationship between the apothem length of a square and the side length of a square? The apothem length of a square and the side length of a square. Remember, an apothem is the perpendicular distance in a polygon. We've often been talking about them in hexagons like this, and it's from the center down. Well, a square should be pretty simple. What is the relationship between the apothem and this? Well, if this is the center, the apothem is going to be half of the side length. So the relationship between the apothem length of a square and the side length of a square is that the apothem is half the side length of a square. And where are we at? Why are we doing 19 on 20 on 72? Y'all probably sitting there screaming or laughing, one of the two. We could have done 19, it'd been a simple one. So scratch that. We're at 17 and we're going to 24. Martha wants to make a regular triangular pyramid out of construction paper. Base is an equilateral triangle. I think we talked about this one. If the equilateral triangle has 10-inch side length and she wants the slant height to be 5 inches, how much material does she need? Round your answer to the nearest square inch. Martha, why do you want to make a construction paper triangle? I don't know. To find the height, you got to find the height. You're looking for a length of 10 and a slant height of 5. So use the Pythagorean theorem to find the slant height. The slant height will be the hypotenuse, which it comes to 8.66. If you take 10 squared It's not the hypotenuse, but anyway, the hypotenuse is 5. So 10 squared minus, if you rearrange the Pythagorean theorem, 10 squared minus 5 squared. So 100 minus 25, it's 75. The square root of 75 is 8.66. So with a height of 8.66, then you use the formulas and add them all together. You need to find the 3 lateral areas, which is 1/2 of base times height, times 3 of those, because there's 3 triangles, and that had a base of 10 and a height of 5, so it's 1/2, 10 times 5, take that times 3, and then add the area of the base. The base was had a side length of 10 and a height of 8.6, we decided. So 1/2, 10 times 8.6. Add those all together, and you should have 118 square inches. Hope that makes sense. The base, I could have drawn it out. We're looking at 10, and then we needed to find this, and so this is 10, and this became 5, and we found this. This is like the flat area, that's 8.66. That's the height of the bottom of the base, if you would just look at a cross-section of the base and pick it up like that. So you found the area of the base, and then you found the area of 3 triangles on the sides, 3 lateral triangles. 118 square inches for 24. And last one is 30. Draw 2 circles with 2 common exterior tangents. There's a range of correct answers here. You could say 2 circles and 2 common tangents, just go 1 and 2 and let it at that. You could came inside and go that way. There's multiple things. You should have 2 circles and then 2 separate lines, each line touching both circles once, tangent to both circles. So the straightforward and easiest is like a railroad car, one here and one here, and it's kind of that picture in your book, so that's maybe what was in your head as well, what some is. Something like that. But you can have different sized circles, you can put them together closer. You cannot have them inside, one inside the other one, because then you could only do one. And if you put them completely inside, you couldn't have any. So it needs to either be overlapping a little bit or touching. You could have overlapping, this one, or you could have touching, or you could have out here and then just two tangents. And you could have even done it this way, like that, and done those 2, I guess, because those are tangent to both. It's a different crisscross thing. And that's it. We will do lesson 73 and 74 next.